video recording and start the course. Start from this week, I will no longer do the streaming. But I will still do the video recording. So in case you miss the class, so if you are sick, don't go to the classroom, right? So you can still see the video recording, right? Okay, so this week we are going to do some descriptive analysis, right? Which means that we have data and we want to look into the data so we have a systematic, holistic idea about the data. Let me say it again. We want to have a systematic, holistic idea about the data, right? Okay, so and today we are going to use an interesting data set. We will have a data frame of comic characters. We have comic books, right? So we have a data set of about 7,000 famous comic characters. We have a data set of that, right? We want to use that data frame to do descriptive analysis, right? So we want to look into this data frame and see what kind of information we can extract it out of the data, right? That's what we want to do today, okay? So today we are going to use this notebook. If you scroll down, right? I say this is our unit front page, right? If you scroll down, then you will see that we will have unit notebook, right? We already have 2 notebook covered, right? So today we are going to do this. Now before that, let me have a quick review on what we have learned, right? And let me say it again, the code and the presentation that I use today can be found here, right? So if you go to this folder, you should be able to download the code and also the presentation slides I use, right? Week after week, every week we will have a page, right? And in this page, there is a material download, right? So you go to this place, you can download the PowerPoint as well as the code and data that we use, okay? But today we do not have a new data and code, right? But today we have a new presentation file. So we are solving problem with data this week, starting to solving problem with data. And then I think, let me use last week's let's do a quick review on what we have learned, right? Okay, because we have 2 weeks already. So I told you that programming is actually, simply put, programming is just one sentence, okay? It is just a process that define or update data object with expression, right? Okay, even you are doing a very complicated neural network model, right? You are still defining data object because a model is actually a data object, right? Okay, and you are using the picture, you are using the article, right, to build that neural network model, and that data itself is data object. The model is the data object. When you use the model to do prediction, the prediction is yet another data object, right? So everything in the world of R is a data object, right? And you can compute the data object by putting this object with mathematical operator, with functions, right? Like sum, like means, like, right? Maximum, minimum, right? So you put together the data object, mathematical operator, and function call, right? You have an expression, isn't it? Right? So use this expression, you can pretty much express whatever you can specify, isn't it? Because the flexibility of the expression, then you can pretty much define whatever data object you are interested, isn't it? Right? So programming is like just defining or updating data object by expression, right? In one sentence. So programming is so easy, right? Why we spend so much time learning programming? What makes it difficult is this, right? It's what you have learned in your assignment, in your assignments, right? This is what you have learned in your data chem assignment, isn't it? Right? Everyone has already finished your assignment, right? Okay, right. So in your assignment, this is basically what you know. This is why make programming complicated. Because yeah, data object has a name, that's easy. But different data object, they have different data structure, and they have different data type. Okay. So it can be structure-wise, it can be a vector, it can be a matrix, right? It can be a data frame, a list. And data type, they are numeric, integer, logical, factor, character string, day and time, right? There are different type of data type. There are different types of data in different structure, and different types of data need to be computed in different ways, right? So that like the mathematical operator only applies to numerics, right? You cannot apply the mathematical operator on character string, right? It doesn't make sense at all, right? And the string pattern replacing type of operation can only work on the character, right? So you have day and time, you have a different set of operation that you can use on that type of data, on that structure of data, right? So that's why programming is complicated, right? And that's why I give you an assignment, right? To get familiar with this common data type and data structure within the R environment, right? So far you already have the idea about the data structure and data types, the basic data structure and data type. You might not be remembered, right? You might not be very familiar with all of this type and structure, but you already have that idea, isn't it? Right? You already have that idea. So based on that idea, today we are going to use this notebook. We are using the comics data set, right? Which is the comic characters in the DC and Marvel comics, right? So this is the data set. This is the data frame that has that composed of this data. So I would like to like have some fun first, right? So we are using this data set to teach you some the most common built-in functions in R, right? Okay, so, and also do some descriptive analysis, right? try to get familiar with the data, right? So without further ado, let's get started, right? Okay, so most of the time, in my class, I will use notebook, right? The PowerPoint slides is just for is I just use PowerPoint very seldom, right? So the major material in this class is actually this notebook, okay? So we will kind of follow this notebook, right? It's easier, right? So in this notebook, first of all, if we want to analyze the data, first of all, we need to read it in, right? We want to read in the data into a data object, isn't it? So we have a function called read CSV. So we can read the data into a data object called D, right? So let's go into the RStudio and try to do this. This time we already say that the way to use the RStudio, right? So this thing are called code chunk, right? So only the content with in this gray area is executable, right? Everything outside the gray area, everything outside the box is actually just comment, right? Okay, so the way we call this a notebook is actually you can actually type anything on the. You can actually type in anything, right? Type in your. You can annotate the notebook and make it your own notebook, right? For example, I would like to put a bullet point here. Say 1. Okay. So I put some text out of this, right, before this code chunk here, and I need the notebook again. What happened? See, sorry, I didn't do it right. If you want to use bullet point, you need to have a empty line before the bullet point. So I'll do it again. Sorry. So everything you type out of the code chunk box will become your own annotation. So you can build your own notebook, right? So after each class, you can actually, during the class, you can type in whatever you want to type in, right? And after the class, you will have a like pretty nice notebook, right? Right? So you don't need to write the notebook on a real notebook, right? In the R programming environment, we write notebook in the computer, right? So so this is the way we use this notebook environment, right? So we usually I would just run through the code, and during the class, if you want to put a note, you can just write the note into this notebook. Okay. Let me take it away. Okay, so this is the first code chunk that we want to execute, right? But every notebook has some format setting and basic setup, right? So this is the first box we need to execute. Usually it would run very quick because the package you already installed. And sometimes it will take some times because if the package that we are using is not installed, it will take some time to do the installation. Otherwise, if you push the button, it would like just finished in a second. And then this is the first code chunk we want to execute, right? We want to read in the data here into a data object. Actually, we can see the data file here. It's called comics1 CSV, right? So the raw data is looks like this, right? CSV stand for comma separated values, right? So this is comma separated value, right? So we can read the comma separated value into a R data object, right? If data is in this way, it's very difficult to use it, right? So so we read it into a data object called D. Now, before I read it, you can see that here it's empty, right? Because we do not have any data object to play with, isn't it? So usually the first thing we do with data is to read it in from some raw data format, right? So we read in this data and let's see what would happen. See, after I read in the data, you will see a data object D, right? So, and this D is actually a data frame, isn't it? This is the data frame of 7250 observation, and it has 9 variables. It has 9 columns, right? Isn't it? So actually, we can see the data frame by clicking here, clicking on the right side of the data object name. Then you can see the see, you can see the data here, right? So we have 9 columns. This is the publisher. It could be DC or Marvel, right? And this is the name. Yeah. This is the name of the character, right? It's Batman, Superman, right? A line. This is actually a categorical column. It means it could be good, it could be bad, it could be neutral, right? And then eye, this is the color of eye, and this is the color of hair. Sex. Living, this alive pattern has 2 different values, living and deceased, right? Okay. And this is the year, this is the number of appearance. Every character has appeared. It appears on the comic books, right? So this is the number of appearance this character appeared on the comic book. And this is the year that this character first appeared. Right? For example, Batman is a very old character. It's like before World War II, right? During World War II, I should say, we already have Batman. Okay, but Superman is actually quite late, right? We do not have Superman, right? Until 1986. Okay. So Superman is just a little older than you guys, right? So it just started 1986. Okay, so now this is the data set, right? And this data structure is what type of data structure? I mean, we say that D is the data object, right? So what is the data structure of D? Is that a vector, a metric, a data frame, or anyone? You should know it, right? Who want to say it? Matrix? No, it is not a matrix. It is a data frame, right? Metric is like 2-dimensional. Data frame is still 2-dimensional. So what is the difference between metric and data frame? we can have we can start to send out our gifts, right? Who can say that? What is the difference between the matrix? What is the key difference between the metric and the data frame? The data chem class already emphasized this. You want to try it?
I think the type of the data in metric is the same. It will be immoral.
You are actually in the right direction. You are actually in the. Anyone want to put some more comment? What is your name? Herb. Herb. Okay. Herb is already in the right direction. Anyone want to do some more, make it clear? See, in data frame, every column can be of different types, right? For example, this column and this column, they are in numeric type, right? And this column is actually a character, because it's name, right? So it's character string, right? And the character and column like this, like a line, it is still a character string, but this is the categorical variable, because it only vary within a few, right? Within a few different factors, right? Isn't it? Right? So in data frame we can have a column of different types, but in matrix, right? In metric, every column must have the same data type, right? Metric is like vector, right? Metric and vector, every element must be in the same type, right? But data frame is more flexible, right? It actually can have different type of column or different type of variables, right? Okay, so it is flexible and it's easier to use in data analysis. So data frame is actually the major data structure that we are going to use in our programming, right? So data frame have in this direction we call it a column, right? And sometimes we call it a variable, right? We will use variable and column interchangeably. Okay? And every row is actually an observation, or it actually represents a subject of interest, isn't it? A subject, a unit of analysis. What are we analyze? We are analyze comic characters, right? So every row represent a subject of research, a unit of analysis, isn't it? And every column represent a variable, right? An attribute of the subject that we are interested in. You get me? Right? So this is the way that we organize data, right? This is the way that we organize data. Okay? So every row is a research subject, is a unit of analysis. And every column is an attribute of that subject, right? It's an attribute of that subject of our interest. Yes.
So like for every data set, it should be it is for.
Can you say it louder?
I mean like for every data set, it should be like this for like the row, the column.
Right. Every row should have the same column, right? Every row should have the same column, right? We cannot have row of different columns put it together, right? That would be another data frame already, isn't it? In the same data frame, every row would have the same columns, isn't it? That it must be this way, right? Okay, so this is data frame, right? This is data frame. And Now let's get back to. So if we, first thing we would like to know is how many characters do we have, right? So you have this function code. This function calls for number of row, right? So you would you put the input D, the data frame as the input, then you will tell you the number of row, right? So this 7250 represents 7250 comic characters, isn't it? Right? And then how many column, how many variable, how many attribute do we have? We have 9, right? We have this 9 variables, 9 columns, right? For every characters. So if you want to see the type, of this data columns, we can use the str function. Now you will say that, how can I remember so many functions, right? Don't worry about that, right? As you learn as I say, right, when you learn language, you don't remember every vocabulary. You don't really need a very large vocabulary. This command would be used very frequently, and you would, like, along the way you will remember that. So str is the command, is the function that we use to see the structure. Str is short for structure, right? To see the structure of this data object. So you can see that you get this many observation, this many variables, and this is the variable name, right? And this is the variable type. See, so only two columns are numeric; they are integer, right? And the rest of the columns, they are written as CHR, mean character, so they are character string. Okay. So this is the data structure. So let's have some quiz. So what is the? I'll do code. Okay. So do I have a name of student so I can? And it should be here. 点名单有没有？ Okay, Susan. Where is Susan? Okay, Susan. What is the? Where is that? Sorry. What is the name of the data frame? I mean, we have a data object, right? So what is the name of the data object? Go back to your data camp, right? See, so this is our data object, isn't it? So what is its name? The name of the data object is D, isn't it? Right? The name of the data object is D, right? So let's do another one. So what is the target is subject of analysis? What is the unit of analysis? What are we analyzing with this data set? What is the subject of analysis? What is the unit of analysis? Anyone? With this data, what is the subject that we want to analyze? Sorry? Yeah, the characters, isn't it? Okay. So what are the attributes of our interest? What are the attributes of our interest? These are the attributes of our interest, isn't it? Right. So every one of the columns is the attribute, is the variable of our interest, right? So and how many number of columns do we have? We have 9 columns, right? So how many character columns do we have? This is a little bit harder. Anyone want to try it? So, sorry? 7, right? Why do you say 7? Because you can read it here, isn't it? You can see the type of the column here, right? So actually, you can also see it in DataCamp. Sorry, in the RStudio, because the structure will show here, right? So you can see that, right? Okay, let's move on. Okay, so the next thing that we want to do is like, now within these 7 character columns, some of them are actually categorical, right? Right? Okay. Oh, so that's categorical is a sense. It's kind of like common sense, right? Now by looking into this data, which of these 7 character variable are categorical? Can you tell? Let me ask again in the other way. Is publisher categorical? Yes. Why do you say yes? What do we mean by categorical anyway? A variable is categorical means that the variable only change in a few labels, right? Like publisher only have DC and Marvel, isn't it? Right? So is name categorical? No, it is not, right? Because it does not change within several types, right? It changes whatever it wants to change, isn't it? So out of these seven characters variables, which one is not categorical? There's only one thing is not categorical. Which one is not categorical? Say it again, louder. Appearance? No. This is not character. These are numerics, right? I mean, out of these 7, the first 7 columns, which column are not categorical? Said? Yeah, the name, right? Name is not categorical. A line, we only have 3 labels, right? Good, bad, neutral. I, we only have like 7 or 8 label. Hair, right? Sex. Okay? Alive only have 2 status, right? Living, deceased. So the character variable that can only has a few value, right? They are categorical. Okay. So now we have in your DataCamp class you learned that you can actually convert categorical columns into factors, right? Which means you want to declare that this column is categorical, right? So and there are some benefit after doing that. Let's move on, right? So see, the first thing we want to if we want to have a whole picture of a data object, the easiest way is do a summary on it, right? Okay, because D is the data frame that we want to see, so we can play a summary function on D, and then this is what we got, right? As you can see that for the numeric variable, it show the statistics, right? It show the minimum, the maximum, the mean, median, right? Okay. It show for the numeric columns, it actually show the statistics of that numeric variable, right? But for all of these characters, it only tell you nothing, right? Isn't it? When you do summary and this character type, if the column is of character type, you actually see nothing, right? Okay, so you have some reason. If it was categorical, if we convert a character column into categorical, you can actually see more information about that variable. Let's do some practice, okay? let's forget about these jargons for now, right? Okay, we will go back to that when we do statistics. Okay. By the way, are you in this semester? You are actually taking a course of statistics, right? Isn't it? Who is the teacher of your statistic course? Sorry. Oh, Cheng Xian 老师, right? Okay. So he will teach you what is distribution, right? What is statistics, right? Okay. This is called statistics, right? And then we will see the distribution later, right? In this course, we will also use the statistics. We will also use distribution. But in R, we will represent statistic and distribution in a different way. We will see that later, okay? Now, see, actually, we want to examine these variables. The first way, one way to understand a variable is to take this is what we mean. This is what we call statistics, right? Minimum, maximum, mean, median. They are statistics, right? So you give it a vector, right? No matter how long the vector is, it has only one minimum, right? It has only one maximum. It has only one mean, isn't it? Right? So this statistics is actually a holistic summary of a data array, isn't it? That's what we mean by statistics. Okay. So if you want to, we have many types of statistics, right? Mean and mean. So very easy, right? If you want to see the means of year, the median of year, or minimum, maximum, right? We can do it this way, or we can do it this way. If we put D and year, right, within summary, it will tell you a lot of statistics at once. Okay, so it's easier, isn't it? Okay, so in this way, we are examining the data in statistics, right, in a numeric way. But in R, we have a better way to understand, to help you understand the variable. We can do it in plot, right? Let's see here. Now, this type of chart is called histogram, right? Do you know what is a histogram? You have learned that, right? You see this a lot. Even you do not know what histogram is. You see this a lot, right? And it's very intuitive, isn't it? We are talking about this variable year, right? Okay, so the value of year is in the x-axis, okay, and in the y-axis is actually the number of occurrence, right? So in histogram, every vertical bar is called a bin, B-I-N, bin, right? I mean, every vertical bar is called a bin. It's just a name, right? A bin. So it has a bin width. So we can see that from 1960 to 1980, there are 4 bin, right? So how the width of the bin is how many? What is the width of each of this bar is 5 years, right? So the height of each bin is actually the number of occurrence within the 5 years, right? Okay, so this is the way to show the distribution of a variable in a graphical way, right? So in this graphical way, it's actually better than this, right? Better than, yeah, looking at this, you still do not have a very good idea about the distribution of that year variable, right? But in R, we can type in histogram and then give it a data vector, right? It'll actually give you a beautiful histogram. hist stand for histogram, right? So if you do hist this, then you'll get this one. Now, in my notebook, you will see something like this, and you don't need to worry about that. This is just for format setting, right? For example, I want to put two charts together. I set the margin, I set the font size, that type of thing. Okay. In your notebook, you can, in practice, you can simply just in your notebook, you can simply type in. Let me do it this way to be easier. Oh. Okay. So if I only put histogram like the here, right? Sorry, it's the broadcasting software is like clipping my screen, right? So it make my see, you can making a histogram is very easy, right? So the way you put the now this is just to put the to change the title of the chart, right? See, this is just to change the title of the chart, right? So you can put a lot of argument inside this, right? For example, color equal to blue. See, you turn it into blue color, right? So the R function is designed with flexibility and convenience, with these two things in mind, right? It is convenience because you can simply just put on a function called like this, right? Without giving him any extra argument, it would make a easy histogram, right? So if you want to make it very beautiful, you need to add in a lot of arguments. It has the convenience, so you can very conveniently make a histogram. But if you want to make this histogram beautiful, right, you will need to put in a lot of argument to change its color, its shape, its whatever. Yes.
So how we know that which is the default?
The easiest way is to put the let me make it smaller so it's easier to see. Okay. We are here, right? So if you put your cursor on a function name and press F1, then you will see an online help of that function, right? So you can see that histogram has so many arguments, right? Whatever you can think of, there's an argument, right? But most of the argument, except the first one, except the input, right, has a default. See that, right? So you can read but actually you don't need to know every argument before you can use histogram, right? So usually you just put the vector inside the histogram data code, and then you get a histogram of it. Is that okay? So see it visually actually give you a better intuitive idea about how the numeric data is distributed across its range, right? Now let's do another exercise. Let's go back to the notebook. So, but when we do D appearance, when we make the histogram of D appearance, you will look like this. What it means? Why appearance is also appearance is also numeric, right? It is also a numeric variable. But when we do a histogram appearance, it will look like this. What happened? What does it tell us? Yes.
Isn't it just saying that a majority of these characters have only appeared between 0 and less than 1,000 times?
Less than 500 times, right? No, it's one bin. The bin width is actually 500, right? Because they are 2 bins in 1,000, right? So the majority of the character, their number of appearance is very low, right? But here 4,000, it means that there are some character, there are some very popular character, they have very high appearance, right? Most of the people actually appearance is very low, but there are some, right? Some character their appearance are very high. Then you will see a distribution like this. Usually when you see a situation like this, you can apply a log transformation, right? The log transformation would actually change the scale in the x, right? Because we are doing log 10, right? So 1 means 10, 2 means 100, 3 means 1,000, isn't it? Right? So if you have some numeric value distributed this way, right? It means that most of the, actually in business we have a lot of distribution like this, right? You can say that almost everything in dollar signs has a distribution like that, right? So if you directly plot that into a histogram, it will look ugly, right? So this is actually the same data, but it let us observe the distribution a lot easier, isn't it? Right? By changing the scale, right? The way to change the scale is to place the log transformation on that numeric vector first, and then again you do the histogram, isn't it? Right? Okay. So we learned this operator last time, right? First of all, we transform. We apply a log 10 transformation on the appearance, and then we do a histogram. And this is just the name, right? Just the name. Okay. Okay. So this is the way to examine numeric examine a numeric variable. But how about the categorical, right? So let's take a break. Take a quick break. We'll go back at